Hello everybody, welcome back to another 3D Hangout. I'm Noe, designer here at Adafruit, and joining me every week is Mr. Pedro. He's right there.
What's going on, everybody? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right, it's a show we combine 3D printing and DIY electronics to make inspirational projects for you. Today's coupon code is NEST, so if you want to pick up anything in the Adafruit shop, you can get 10% off your order if you use coupon code NEST at checkout. Thank you guys so much for joining us in the chat room. We are live streaming today and every week. It is, of course, Wednesday, March 29th, episode 100 and something.
Yeah. I had in one of these notes, 123 or something like that.
I think so, something like that, in the hundreds and 20s. So, how's everybody doing in the chat room? Welcome, everybody. I'm getting links together here.
Shout out.
Okay, shout outs. Do that.
Zach, Joni, Stuff with Kirby, Ryder, Johnny, or Yanni, Stan, Jello 3D, AT Makers, Jess, Lewis, Pixel Paradise, Matt Zero.
Fine people.
Welcome.
Because you're joining us. Thank you so much.
And I think it's Ryder who noticed that, yes, we got rid of the blackout curtains behind us.
You may notice that we're a little bit brighter. That's because we used to have blackout curtains, and we took them down.
Yeah, so the main reason was when we were doing time lapses, a lot of the exposure would change throughout the day as we're doing a time lapse. But it's working out pretty far. We've done a couple time lapses so far. We just point the camera down, and set the exposure and the white balance to manual, and it works out pretty good. So I'm gonna try this out, give some more light into the room, and yeah, that's the difference with the background, if you guys notice that.
Yeah, it really helps with lighting. Lighting is probably the most important thing about photography. Yeah, I see. Ryder is saying my mic isn't on. It's on, it's just, I guess, low. Sometimes it happens. Yeah, sorry if that is bothering your ears. Yeah, it's really low. Let me see here. That's the difference with the back. How's that? Is that any better? Actually, this isn't really doing
Oh wow,
much.
it is off.
It's off?
It sounds like it's off.
Yeah, it does. I'm not sure. I'm at a pretty high dB here. How's that? Is that any better? It says it's peaking now. It's still not on.
Are you plugged in?
Yeah.
Like in the back?
Man.
Like it sounds like you're not even on.
It's on.
Sorry, folks.
Yeah. We thought we figured this out by now, huh, in episode 100. Yeah, it's, it could be the two-way is different. That could be it. Could be the two-way. I mean, if I talk right into the mic, you can clearly see the levels are up, right? So we just have to talk like this for the rest of the show. That could be it. Can you guys tell I really hate lava mics? They're
Yeah, it is off.
They're terrible. So I'm just gonna talk like this for now.
Do you want to just use my mic since this is really
It's kind of split, so I think it'll be fine.
Yeah, I can hear you.
Yeah, I know you can. The problem is I don't know fully what the problem is, but I know some days, some weeks this happens, and I haven't figured out why. Some weeks are better than others.
All right, let's continue with the show.
Yeah. So this week's guide and project is a feather box. It's a very simple multi-purpose enclosure for the Adafruit feather boards. So this was sort of commissioned by Bill, who's in the chat room, who runs AT Makers, and the sort of goal with this project is to make a multi-purpose enclosure that can be used for a wide range of different projects. So we had to really think about different applications and try to make something that will work for just about everybody. So hopefully this does that. The guide just kind of walks through the different pieces, what you'll need to kind of assemble your own. Obviously, you'll need access to a 3D printer. If you don't have a 3D printer, I do throw some links out there for 3D hubs and Make XYZ. Or maybe your library or a makerspace if you want to get these printed for you. Definitely check out the 3D hubs or Make XYZ, because a lot of local makers can get some good use out of their 3D printers. Maybe high school, maybe maybe something like that. Let's see. The next page talks about the parts. So there are different versions. So there are some versions that are simplified, that don't have everything. So the main things that are kind of different about it is not really sizes, but kind of mounting tabs. You can have it on either the case or the battery holder. A switch holder, so if you want an integrated power switch, you can have that either in the case or in the battery holder. The battery holder itself can hold up to a 2,000 milliamp battery, or you could put a 500 milliamp battery or smaller. So anything bigger than a 2,000 milliamp battery I don't think will fit. You do need some screws, some hardware, in order to mount your feather into the case. So with some projects, I've made it so that I've 3D printed these little kind of nubs that protrude from the standoffs, and that allows no screws. But sometimes some printers don't really perform that well, so I figured to just use screws because that's just a more sturdier approach to secure a board to something. The case topper, currently there's 3 different types, which I only have 2 photographed here, but the main ones are the topper wing, which has a complete cutout for the entire PCB of the feather wing. Any feather wing. All the feather wings have about the same size, so the cutout hopefully works well. If there is a feather wing that doesn't, we can easily make an adjustment to it. And then there's a really simple one that it's just fully enclosed. Another one that I have photographed here is one that has 2 cutouts for the headers. So the feather has 2 kind of headers, so that will just expose the headers so you can still have them. But you could just use the feather wing topper if you want. Download the files. I have them available in the 3 usual suspects, so Thingiverse, PinShape, and Umagine. Also, the source file for Fusion 360 is available to download as well, so you can download it as an archive or download it as a step file or a set file or anything like that. So it's not limited to just Fusion 360. The CAD page talks about what is editable. Everything is editable, but there are some user parameters that are built in, so if you want to make some quick adjustments, you can totally do so. So I just kind of break out the main ones here. And what I'll do is I'll have a layer-by-layer tutorial on how to modify things outside of the user parameters. So if anything breaks, or if you want to make a completely custom one, you can do that. No problem. 3D printing just talks about kind of be aware of your slicer's sort of tool path, so optimizing for tool paths. Some basic settings that worked out for most printers. Having a good first layer is incredibly important. Those type of things. So hopefully this helps out. And the assembly just walks through how to mount the feather to the board, to the enclosure. Pretty simple. I'm sure last week you remember we did a slide switch JST adapter. So I have that as a prerequisite. So if folks want to build that integrated slide switch into their feather case, you can totally do that. Or you can wire it directly to the enable and ground pins if you want to be able to turn your feather off when you recharge. But some projects maybe don't need it. Maybe the project can stay on and still recharge. The feather can totally do that. That's kind of it for that one. Usage is just sort of like, hey, there's mounting tabs, and you could still access the headers for prototyping. And then the last part kind of talks about if you have any suggestions or any comments or anything like that, I invite you to have a conversation here on the Adafruit forums. I think it's wise to use our Adafruit forum since we house it and we host it. Instead of having a conversation like on Thingiverse, it's, I think, much better to have it on Adafruit's forum so that we can keep a log of everything. And you can have these long, drawn-out conversations and share photos and links and all that sort of stuff. And one thing is I posted this 2 weeks ago, or last week, I suppose. Yeah, March 20th. Kind of as a soft launch to say, hey, here are the parts. I put them up on GitHub. I'll continue to update them on GitHub if we do updates. And Kevin in the Adafruit forums did a little quick request if I could export the Adafruit feather component and the wing as an STL file so that he can use them in Tinkercad, because he wants to use Tinkercad to make his own custom enclosure or mounting bracket. So I went ahead and did that. So I exported these guys out and dusted off my Tinkercad account because I haven't used Tinkercad in quite some time. So if you want to reuse these STLs in your project, you can totally do so. Kevin wanted to kind of use the mounting holes. So this helps him get the proper clearances and the correct dimensions for making his own case. So it worked out. It's working good. So if you have any questions or comments, now you know where to post them, right? So it's helping out Kevin. Glad that helped out. I still have these available on GitHub, which I will link in the guide because I haven't done that yet. But wherever you download them, you know what I'd like to do is to have a GitHub repo for to house all the STLs, and then just use Thingiverse in Pinshape to not actually house the STLs, but to just link to them. Because then because I love how you can quickly push updates through GitHub. It's so easy. I don't have to.
It's one central place. You don't have to update it to like 4 different.
I know. Yeah,
repos.
It's really fast. So I wouldn't have to update to, like you said, 4 different websites. So maybe we'll do that in the future. But this is the first project where I kind of have it up on GitHub. So that's the project. I hope it's useful for you guys. And if you have any suggestions, again, you know where to post them. I'll have this linked. It's linked in the guide. So go check that.
That's right, Feather Box. 1,001 uses.
Maybe. Yeah, there's a lot of different ways to configure it too. So we'll see. The plan is to continually update this and just hammer away and chip at it as folks find it different uses for it. So yeah, I think that's it. Again, big shout out to Bill Binko who really kickstarted this project. Because normally it's like, well, generic case is nice and all, but we want to make it into a cosplay prop or something specific that really drives people to check out the Adafruit Feather. But I think having multi-purpose case is really handy.
Yeah.
So there you go. Thank you, Bill. And we will continue to do some more collaborations as we get to them. So again, if you want to pick up some Adafruit Feathers, check out Nest. All the feathers are listed at adafruit.com/feather. That is the kind of landing page that shows all of the feathers that are available. There's about, 20 or 30 odd feathers? There's a whole bunch. Just awesome. Here it is. All the feathers. Yeah. Now, all of them haven't been tested. Like, mainly the radio ones. What's it called? The LoRa's?
The LoRa radios.
Yeah, LoRa radios. I haven't tested those out yet. So the main thing is that where the USB port is, they all have the same mounting holes. But the ones in the back are the ones that change. So that's why we have slotted mounting holes in the back. So hopefully they all fit. If not, we can easily make an adjustment for it and maybe push out like a specific case for a specific feather, like if it's a special one. So that's it. Cool.
Yep.
Thanks for the link there.
Yeah, we're still waiting for our NRF 52. I think we ran out of stock before
we couldn't get
shipment
one.
went out. That's cool. Bill Binko was saying that Thingiverse actually has an API for uploading and updating STL files.
Yeah, so we could write a script
Cool.
that can update to Thingiverse whenever GitHub changes. That'd be great. That's a good idea. Okay.
Well, that's something to look
I'll
into.
see if, I'll ask one of our web teams if they have some cycles to do that. All right. Again, coupon code, Nest.
And did we go over all of the usual stuff like shipping and?
No, we didn't. So we got some deals going on, as always. There's a deal going on with UPS where if your order is over $200 or more, you get free shipping from within the States. So that means if you order a 3D printer or something large, you can get free shipping on that, which is a pretty great deal. If you're in New York City, we have same-day delivery, which is something that's working out. We also have adafruitdaily.com is where you can subscribe to daily doses of, they're literally daily emails.
Mm-hmm.
So
Tips and tricks on maker business.
Sorry.
I already got one. Biohacking, MicroPython, 3D printing, wearables, and electronics. So definitely check that out, subscribe. Get your daily dose of tricks and tips.
Yes. Again, you have to opt into that. We don't do that automatically.
Mm-hmm.
All right, so the next thing we're going to talk about is what we're prototyping. Pedro's got 2 projects going on right now.
Oh, let's leave this real
What's
quick.
that for?
Just to take a
Hey,
look.
look,
at
we
the
have
tiny
parts.
little bonnet.
The bonnet came in today. This is a Joy bonnet. It was last week's project. It was released last week.
So we literally just got this in the morning.
Yeah.
So just now started laying it out and seeing what the size of these are.
Yep.
I don't have big hands, and it is itty bitty compared.
Yeah, it's a little tiny.
So we'll definitely try to make a itty bitty little tiny gaming system with this.
Yeah.
Portable, fully enclosed. So
There's
just got
some-
these parts.
Yeah, there's
Literally
definitely some
just-
design decisions to be made here because it's designed to kind of fit this way. And there's not any GPIO left for the screen, so we have to figure out a good way to connect everything together, really. So we'll give you more updates on it, but we just got them in, so we'll let you know.
Still working on the Logan's Run palm flower? No, they call it life clock in the movie, but it's going along. It'll be released next week.
Oh, it's completely done.
Simple little enclosure, Gemma
Yeah.
jewel inside, twist together case, little 550 milliamp hour battery inside there, using transport to connect to your body. So working on that. And then following week after that, we got the flexible Lego tape. Popular YouTube video that came out there on an Indiegogo on a bunch of flexible Lego tape that you can like attach to the wall, corners, and whatnot, and still have all of your Legos be compatible with that. So we're just going to be using like double stick tape or foam tape if you wanted to make it permanent, if you want the Craggle effect on there. But all the Lego bricks work. We're using, first we tested it out in Cheetah, and that worked out fabulous. And then because we have so many colors in just original NinjaFlex, which is the more softer, rubbery type of the flexible material, I didn't know if that would work or not, but the tolerances stay the same. You can hear the clicking when you attach bricks and reattach them, so that worked out really good.
Yeah, this surprisingly worked out well. There's not much to it other than just getting the tolerances correct.
Yeah, I mean, you can grab the STL files for the LED Lego brick that we just worked on, and all of those are exactly the same, all the
So
same
there was
radius.
there's no tweak there.
There was nothing that I needed to change for the tolerances, and this is a really cool little layout to visualize all the different types of colors that we have in NinjaFlex. I think it's the most colors that we have in the shop. And
Yeah,
even
there's
in
some
the
colors we don't stock, but
yeah, mainly like the yellow.
Yeah, but we have lots of them.
So this turned out really good. We're actually gonna go to the Lego store and shoot some footage over there, stick these on, get people's reactions of what they think of a nice little flexible Lego
that might
tape.
be interesting. Yeah.
But-
So there's some things that we can do other than just make these strips. We had some thoughts of putting them to have kind of sewables to make wearables, so you can put them on a hat or a shirt or a bag.
Yeah.
I had a thought of making it into this wristband. That you remember
That'd
the
be
Apple
cool.
Watch wristband? Maybe that's feasible. It's doable. Absolutely doable. So there's some ideas floating around. As far as 3D printing it, we have a guide on how to print NinjaFlex. You've tested both NinjaFlex regular, which is the 85A shore hardness, and the Cheetah.
Cheetah semi-flex
Which
works
is
as well.
95A.
This is actually the semi-flex that I used to test
Okay.
it on, so it all works. All the
Yeah.
tolerances all work the same.
Cool.
So this will be a nice little fun project, nice little buffer. But yeah, definitely when we do the wearable part of it, it'll look cool because you can like design a little scene on your hat or your shirt.
Yeah.
Or I think one of the things you said was like having it like there's like a bandolier or something, like something on your shirt or something.
Yeah, I forget what they're called. The
But
things that
that'd
go
be
here.
cool. And again, check out the tolerances on that.
Yeah, it's pretty good.
Make like a magic carpet or
Yeah.
something.
Now you might notice there's and it's NinjaFlex, so retraction.
It's pretty cool. Like how it looks like a rainbow.
Yeah. Okay. If you guys have any ideas, you can let us know.
Yeah, but definitely the wearable thing is what we're gonna showcase this as
Yeah.
some of the hero shots, wearing the hat and whatnot. But that should be fun.
You could do this today, guys. If you have NinjaFlex and 3D printer,
Yeah, you
just do
can
it yourself.
grab like I was saying earlier, you can grab
Yeah.
the Fusion files and get
Yeah,
the
just
radius,
get
the
the-
patterns. They all work the same. The only thing I'm doing different here is
Right.
just laying it out in a long strip. And I'll be uploading several different sizes too, depending on what your bed size is. If you don't want to mess with any of the Fusion files. It'll be
Well, that's
different
one
sizes
thing
of
that I took a look at when I saw you designing this. I was thinking of it as a challenge. Like, well, how do you make it parametric using user parameters where
absolutely.
you just say I want a 4x16,
Mhm.
and you just type that in and it would do it. Right now, I don't know if there's a way to do that. There might be, but I don't know what it is.
Yeah, so,
Because sure, you can make user parameters, but to make it so that the extrusion gets updated, I'm not sure how to do that yet. Yeah, so there's some opportunities there to kind of learn a little bit more about being parametric, especially with this design.
Yep. People in the chat are worried that this could be copyright issues with this.
As
Well,
long as we don't say it's Lego.
We don't sell any.
Yeah,
of
we're not
these
selling
designs.
these. It's just that this
we
is,
give away
this
designs.
is an STL that you can download.
Yeah, it's the same thing with like the Pi Girl or the.
Yeah, we don't sell the case because we can get you
Yeah,
can
yeah.
get some sort of legal thing.
We
so
sell
it's-
materials, printers, and electronics to build whatever you want.
Yeah.
So that's how we can get away with that.
Why don't you use OpenSCAD? I'm not programmingly minded, Kevin.
Yeah.
So OpenSCAD isn't something that I know how to use.
Yeah. If you can do it, post it up. We'll share it.
I believe somebody maybe already has it made on Thingiverse, so maybe
I'm
just use
sure
that and
there's-
printed it on.
I'm
you know,
sure
just
there's a
print
couple
it.
already. Yeah.
Maybe just print it. I think there is. There's got to be. I think so.
I'm sure there is.
Yeah, there's nothing special about it. Again, it's just
Mm-hmm.
just a strip. Yeah.
Yeah, it's just a
Yeah.
7.8 radius.
I think the value
with
is in
a-
how you use it. Right?
Yeah.
What creative thing you can do with it.
Yep.
Okay.
Yep. Other things we're working on.
If you want to pick up NinjaFlex, 10% off.
Actually, no, that's it. Just went through it all.
Yeah.
All right, let's jump into this week's shop talk.
Shop talk. I actually want to talk about something that is kind of near and dear to my heart.
Yeah,
sort of,
so
somehow.
on March 31st, we will say.
Farewell to 123D Design. Oh,
Yep.
no. March 23rd, there was an update to Fusion 360, our CAD package of choice, and they added an importer for 123D Designs. So before, you'd have to kind of do this kind of like zip hack, is what it's called, to get 123D Designs into Fusion 360, but now it's built-in. It's built in to Fusion 360. So if you do an update, you can totally import all of your 123D design files. So this is just the changelog on Fusion's website that tells you what's new and what's changed. So that one really stuck out. They also, if you follow Fusion 360's YouTube channel, they came out with a video on how to do that, how to use it, which I'll have linked down below. I think I will share it on the blog as well, right? If not, I will. So I was going to show you guys how to do it real quick. I think I can do this one-handed, maybe not. But it's pretty simple. So maybe just do it real quick. Hopefully it doesn't take more than 5 minutes. So in Fusion 360, you just click on the upload thing. So this is where you upload your files. You select a file. And this is a 123DX file that I exported out of 123D. So I have quite a few designs made in 123D that I haven't put into Fusion yet, mainly because it takes a little bit to do that hack, so I don't have to worry about that now, so I can just kind of freely open it. Well, you still have to upload it into Fusion, into your account, so I'll hit upload, and it doesn't take too long. I think it takes like maybe 10 seconds or so. But if you're worried about the cloud, like, oh no, I don't have this locally, you can always save your designs out locally in Fusion. Yeah. There's a couple different ways to do that. You can do a shared public link and then download your step file, or if you want to download your Fusion archive, I believe you log into a360.com, which is like the back end sort of data management for your account, and this is free. A360 is free with the license, the maker license. That's free to use. So now that it's uploaded, It basically just shows it wherever you uploaded it. So I have it in my Adafruit's projects folder, so I can just double click on that. And this is one of the projects that there's a lot to it, and I think I kind of didn't tweak it as much because it was kind of difficult to do parametric updates in 123D design. So I think there was a lot of opportunities missed to make this parametric driven. So this is the ray gun that I made a couple years ago, and it has a whole bunch of different electronics in it. And one of the things I wish I could do was just kind of hide files this quickly. I could click on a surface, hit my hotkey, and then just kind of step into the file. And I have a browser here. These are little details that I take for granted now, where it's like, well, of course you have a browser with all your solids laid out. Well, you don't have that in 123D design or Tinkercad for that matter. So you outgrow your file when you're spending all your time just hiding solids to get into your design. It was a pain. So to get in here and to get all these components in here was kind of a little bit of a cluster. I don't have a good analogy. It was just a pain in the rear. So this is nice.
Yeah, again, you're hitting the V key to
hide stuff. Yeah, because I'm using one hand here to do this. So that's it. Very, very simple. So if you got your 123 designs and you want to bring them in, obviously I think the first thing you want to do is right-click on your main assembly here in the browser and then hit capture design history. That's going to allow you to, whenever you make edits, you can go back and update features, values, all those things. So I think from the main thing I would do here is to kind of assign tolerances or assign user parameters so I can easily adjust some tolerances, so some of the things might not fit all that well. So yeah, cool. All right, so 123D, last day to download it is March 31st.
Yep.
It's no longer going to be supported. And I can see why they did this, because 123D was kind of like they had an iPad app, an iPhone app, and probably an Android app. I'm not sure.
Yeah, so the development team on any application isn't that huge, so they had to always split resources, because they're working on Mesh Mixer as well, Fusion 360, Inventor, so it makes a lot of sense to consolidate everything, make all developers' lives a little bit easier, and integrate a lot of the features into Fusion 360. So. That's right. It will continue on in code and spirit.
Yeah. I used to see 123D as kind of like a baby version of Fusion 360, but it's kind of limiting because like the things I talked about, just being able to see your layers, your solids. All right, that was my little bit.
Bid it adieu. Okay, next up. BCN Sigma R17, still doing some tests on the brand new unit released by the fine folks over at BCN Technologies. Last week we had a little bit of issue of showing the screen.
This time I'll remember to show the screen.
So just real quick, on the first thing that I tested with it was, of course, using 175 on it, since it seems to be
175 filament, not screws. Filament.
Yes. Yeah. So the first thing I did was take out the stepper driver, the motor, the way that it's mounted. It's not too hard to get out of there. And then there's this one screw that you can see right there that I took off that actually blocks it from being able to fully grasp onto the thinner filament. Once you take that out, you can remount it, and it works pretty good. I'm using the ProGen generated profiles for Simplify 3D. They do have Cura versions as well. And you can check those out. Use those. All you got to do is change the diameter to 175, and it works pretty flawlessly. So one of the issues that I was having with it was with 285 and 175 was I was getting these ringing artifacts on the side. So if you switch over to the picture to show that. You can see there a bunch of ringing artifacts. So it turns out that it was over extrusion caused by the way that the post-processing script is doing the extruding on this. So if you grab any of the ProGen profiles, you can just go to bcn3dtechnologies.com/.
I'll have it linked below. Don't
You
worry
can
about
just
it.
search BCN3D ProGen. It should come up.
Yeah, it was the first choice, the first search result in Google.
Yeah, so you can see all of the little drop downs here if you're doing a dual extrusion, all of the number of different nozzles that they now have. You can set those up. And once you download that, load into Simplify 3D. The setting that you want to change to eliminate some of that ringing is going into the script tab on the inside of Simplify 3D.
So I selected my profile.
Yep. And then we'll go over to scripts. And then if you look at the additional terminal commands for post-processing, if you look at the very first one where it says outer parameter, S310 seems not to work as well. So when I tried printing out at a higher detail, I didn't have any of those ringing artifacts. So it turns out if you click on it and you take a look at the motor command that it's giving it, S160 seems to be the perfect extrusion for that. So I switched to that and it came out beautiful. The only other thing that I changed was the speed. I was able to bump that up to 85 millimeters a second. So then I have a fast part and no ringing on it.
So crank that up.
Yeah, 85.
85.
Yeah.
Okay. What about keep the movement?
Left
at
all
200?
that. Yeah, the outer speed dropped it down to 40, which should be the standard for the fine.
Okay.
So drop that down to 40, and of course the filament diameter based on whatever that you're going to use.
Okay.
And that came out excellent.
Did you use 175?
I used 175 for this.
Okay.
And I posted this on Instagram, but I don't know if you can go to the overhead.
Yeah, let me see if I can autofocus that for you.
It's a little chest piece of the Queen. You can find this on a Thingiverse file, or a Thingiverse upload, was the chest project. You take a look at, this is at 0.06 millimeters.
Go ahead and get a little closer. There you go.
And it's pretty hard to decipher the layers on this. How smooth that came out. So I'm very happy with this. So the other tests that we're going to be doing are the dual extrusion, since I just didn't have time to get to that with the workload. But wow, yeah, check that out. Fabulous job. Just a little bit of drooping here on the
Well, yeah, I mean, it's just
glasses.
floating in the air.
Yeah,
It's
they did a pretty
incredible
good job.
that
You
it
can
did okay.
definitely clean that up. And yeah, I am really
Yeah, it's
impressed with
great.
that.
Good.
Silent, with their new drivers, the
Yeah.
motor drivers,
Nice and quiet.
nice and quiet. Can't even hear it when it's printing, but it's pretty cool.
Yeah, we're still working on getting them in the store. So
Mhm.
that's it.
Yeah, we actually do have the older model. We're trying to see if we can swap those out for the newer ones.
Mhm.
So
Yeah, because they were kind of stagnant.
Mhm.
Yeah, this is a whole story, but don't need to go into that.
Yep.
Okay.
let's see what else we have in here.
I think I had some other stuff. So we got a 1 millimeter nozzle as well.
Yeah.
So Pedro can show that off while I look at this here.
Yeah, so they sent us over this guy to test out. This is what it comes in. And one of the differences you can see right away is the much bigger heating block that it has on here.
Yeah, so 1 millimeter nozzle is quite large, and the first thing we wanted to do is to see if we can print something large but fast.
Mhm.
So we found we tried one of my designs, the Nintendo Switch stand first,
Mhm.
and then I found a laptop stand which is really large, and I tried printing that as well. So that's what that is. You can't even see the layer lines because it's overblown, but
Oh, yeah.
this was. I'm just gonna show the video. It's not gonna work.
No, you can kind of see it there.
Yeah, this one shows it better.
Okay, yeah. So I posted this on Instagram too if you want to get a clear picture of that. And the crazy thing about this is usually this would have taken.
Yeah, so it's Fusion 360. Simplify says that it calculates the time as it's 12 hours, around 12 hours to print with a 0.4 nozzle with a 0.2 millimeter layer height. So this print should take about 12 hours. But we were able to print for 3 hours. Yeah, so like 2:50, 2 hours 50 minutes. So about 3 hours The problem is, as your nozzle is bigger, you kind of have to print slower. So we had to drop it down to 30 millimeters a second.
Yeah, it's one of the things that you don't hear about too often.
Well, I mean, that was the takeaway for me when I watched Aiden's video on using a 2 millimeter nozzle. Is you have to print really, really slow, and I can see why. So
definitely useful for huge projects.
I think it has some reason to it. Although I think I prefer the 0.6 millimeter nozzle because
you're able to get a lot more finer details on it.
Right, and still print fast. So like at 60 millimeters a second. With a 0.5 layer height, I think it was. What layer height did you use for this one?
0.6, I want to say, for that one. And it didn't come out that much better.
Yeah, the support material was rather difficult to remove. So,
and this was when I set the separation layer to
2 or 1.2 millimeters.
I think it was 2 millimeters, and it was still difficult to remove.
Oh,
yeah, just because
I broke the part. You can see here, I broke.
What are we showing?
Part. I'm showing the screen. Here, so I broke the part trying to get rid of the support material.
You can kind of see it right there.
Yeah. The red one is printed with a 1 millimeter nozzle, and the black one is the 0.6 nozzle. So I think another comparison here is the print time. So I know the black one printed the 0.6 nozzle. Oh boy. Yes. 0.6 nozzle printed an hour and 30 minutes. But this one printed like longer, I think. I'm gonna say like
just because we had to slow down the speed,
right?
And so we were still able to get these really gnarly artifacts for the retraction across there. Yeah. So it definitely depends on the geometry that you're printing. If it's something that doesn't have a lot of islands or something that doesn't have a lot of supports, you're gonna get better results out of that. But I think for parts like this. The 0.6 millimeter nozzle was able to print faster, better quality, and the support material wasn't too terrible to remove. It was a little difficult, but not as painstaking as this guy was. So some things I want to test out are using NinjaFlex for this, for making like a tire for a skateboard. Okay. So like wheels and tires for that. So that might work out pretty well. But
I think as you go bigger the nozzle, you don't really go faster in terms of printing speeds. You go slower, so it doesn't really speed up the printing process. I think the 0.6 nozzle really is that balance in the middle where you can still push out a lot of plastic quickly and still cut down your print time, but not have so much. You can have a little bit more detail than the 1 millimeter nozzle. Yeah, and Kevin Osborne in the chat room is saying that large layer heights are really good for transparent material. I have read that. Yeah. And I did notice that. That's something I didn't even know about. Wow. Yeah, so this is a translucent red, and I did notice that. Look at your hand. Yeah, it does have better transparency than I usually get out of this. So that is a very good point. Wow, I didn't know that. If you're making like a visor or something like that, you can use a translucent material, and it should be able to see through it a lot better. Wow. People are also saying that PETG should work out pretty well for doing transparent applications. So yeah, those are still some other things I want to test out as well. Sweet. All right, so that's just our initial testing with the 1 millimeter nozzle. The fine folks at BCN3D are printing some cool stuff as well with the 1 mil nozzle. Yeah. Again, like vases, cups, things like that that don't require a bunch of crazy geometry. I'm hoping brackets and some industrial type parts might be stuff like this. Yeah. Came out really good. Shame you can't see the layers on this, but you can check out the Instagram video if you want to see. Yeah. Almost worked out there. You can see. Here's a better video for it. I think this is the one you shared. Oh yeah, check that one out. You can really see the layers on that one. So this is at 0.5 layer height. You could probably go higher, or no? I think the max might be 0.6. But yeah, look how fat that looks. Pretty satisfying seeing that come out. Yeah. Yeah, I was really just trying to print something that didn't have a lot of detail to it, just something that has like, perimeters. I turned off infill, I turned off the top and bottom layers, so it's fully like, it's just perimeters. I just wanted to see how tall this thing could go.
And what I was really surprised with this is that we were using 175 millimeter filament on these, and it was able to extrude this fast enough to at 1 millimeter, because it almost looked really close to the diameter of what 175 was. So
it's just a little off.
It was really freaky to see.
Just 0.75 off.
Yeah. All right, cool. So we will continue testing 1 millimeter, the Sigma R17, and hopefully have those in stock pretty soon.
Yay.
Now, you updated your microphone adapter recently. I think you got photos of that.
Sure, yeah. So if you want to check out, I just made this yesterday. I figured I'd share it today. So good use of like practical 3D printing. This is a 5-minute modeling job, and it took about half an hour to 3D print. So it is basically just a right-angled version of this tripod adapter. So it takes a standard microphone thread size. So that is a 5/8 of an inch with a 27 thread to a 1/4-20 tripod screw size. So what I did was, let's see if you can see the photo here. I basically mounted this little printed piece to my mic stand, and then I added our tripod swivel head onto the microphone so that I can swivel the head around and have different adjustments. We sell quite a few different tripod kind of pieces, odds and ends. So this is the little swivel pan tilt thing, which I think we have a pretty good price on it for $5.
Actually, this is the cheapest price. All of our camera parts are way cheaper than any. If you look through Amazon,
B&H, most camera accessories are very, very pricey. Even the smallest thing like this. So we get it directly from the manufacturer, so we're able to give you the costs. So we have a bunch of other things. This is a really useful one as well. It's a 1/4-20 screw D-ring, so that one was nice. And just a couple other different things like thread inserts. Yep. We'll probably get some more tripod stuff as we see them useful.
I mean, there's another tripod episode coming up with the Nintendo Switch holder, so stock up on these if you want to build.
Yep,
those.
You can get 10% off if you want to get some tripod stuff. Nest. Use it.
Use it or lose it. All right, this week's community makes.
Is that it for Shop Talk?
Publishing on the Adafruit Learning System.
I don't have any imagery for it, but if anyone's interested in getting your projects published on the Adafruit Learning System, the best way to do that is to document your project and then share it on a site like Instructables or Hackster.io, HACKADAY.io. All those are fine places. That way you already have
proof that you can write.
Proof that you can. Just something. It's like your resume, right? You're building up your project, showcasing your documentation skills. That's the best way to do it. Is to actually do it.
And of course, come on the show and tell, so we can actually see your face, see how you present the project. If
you look at it from like a linear way, kind of steps. Step 1 is to document your project, right? Where's the things? Is it right here? Okay, cool. Sorry. Document your project, publish your project, and then go on the show and tell. Yeah. It's that simple. It's easy as 1, 2, 3D, right? So I wanted to say why documentation is important. One, it's reference for you. So if you ever want to build it again, you have a reference to it. There's many times where it's become useful where it's like, I need to build this again. Oh no, I forgot. Like, when did I do that? So you're not going to remember. I don't remember what I built a month ago, 2 months ago. So that's why it's really important to just have a reference for yourself and, of course, for others who can do it. It kind of helps you with your writing skills. You have to kind of write stuff, so it makes you think about your project and maybe even optimize as you're building it.
And step-by-step of instructions.
So sort of like the order of operations and thinking about that. And another thing is if you ever want your project to be published in a publication or a magazine, it's easy for you to do that because you already have everything written out and you've taken photos, right? Taking good photos is a whole nother topic, but it's very important. It goes hand in hand with documentation. But it's not to say that, if you don't have a good camera, don't take any photos. Just take photos and document your stuff as best as you can. So we have a lot of contributors from the Adafruit Learning System started off sharing their project on the show and tell, and that's really the way to kind of get your stuff seen. That's, I think, the only way to get your stuff seen directly to Lamar and Phil, because they're there to see it. Sharing it on Instagram and Twitter is great too, but going on the show and tell really gets you seen, I think. So hopefully that was useful and is helpful. Okay, now we can do community makes. So I got some couple projects here. Again, if you guys want to share your projects with us, you can do so by tagging us on any of the social channels or emailing support@adafruit.com. You can always do that.
Or marking it as a make on any of the STL repositories. That's always a good way to get notified on that.
This is a printed place cutlery, so it's like a butterfly knife, but like there's cutlery there. It's kind of fun, interesting project. Yeah, I just saw it pop up from Colts 3D, just another repo site. Pretty neat. This is a Squid Koozie. The print quality just looks excellent. Like, just looks beautiful. The print quality. It's a squid. Reminds me of like Octoprint, but it's a koozie. It's pretty neat. Very nice detail, design. Not much support material required. Pretty great. We'll probably print it for Time Lapse Tuesday, right?
It's very nice.
This is a smartwatch built with based on the FLORA and the BLE module. So it's 3D printed case, and there's the project is up on HACKADAY.io. So all the sort of source files and things are here. So it's a pretty awesome project. So check that out. Another project, this is from David Johnson of DIY Engineering. He made a more affordable version of his retro game, his Raspberry Pi, RetroPie arcade handheld. It's pretty nice. Good combination of 3D printing and laser cut and CNC milling. Different materials mashing together. Very, very cool. So from an inspirational standpoint, you can check that out. Very nice design. I want to give a shout out to Naomi Wu, who is now a contributor on HACKADAY. So she made an article on how to source projects on, I'm not sure how to pronounce it properly, Taobo? How do you say it?
Sounds pretty great.
Taibo? Sorry. So it's really nice to see her work being featured on publication like HACKADAY. So it's great. If you want to see more of her projects, you can follow her on Twitter. And I'll have this linked below as well. I think that's it. Community makes. That's it, guys. If you want to share your projects again, hit us up. We'd love to share your project.
Oh, you missed one. This week's Time Lapse Tuesday was the Zelda planter from...
Yeah, that was last week's Community Makes. Oh, this week, we printed it, and we have it, so we can talk a little bit about it.
Yeah, so here it is. We printed it on the Ultimaker 3. So our first attempt at this, I used the giraffe setting, which is a 0.2 millimeter layer height, and I forget what the speed was on that, but it didn't come out as well until I dropped it down to 150 microns, and that came out excellent. You can see that there are no contamination between any of the colors, and I didn't even have to do any of the calibration since I updated to the newest firmware, and it came out really good. I tried this out on the BCN 3D, but again, I used the 0.2 millimeter layer height on that, and it didn't come out as great. So I'll try 150 next time.
What size filament?
So this is 2.85.
Okay. Ultimaker filament?
Ultimaker filament.
Might as well use it.
What was the heat? I think it was like just at 205 for the heat, 60 for the bed. I did have to use blue painter's tape just because of the fillet that's on the bottom here.
Oh, yeah?
And usually just using the glass bed works pretty well, but anytime you have geometry that has such a huge fillet, it's going to lift off. And I think it was a 6 millimeter brim that I used around there as well. And it came out excellent. So if you guys want to check out a nice, simple, modern planter for your desk, check out Augustine's Zelda planter.
Yeah.
Very cool.
Augustine.
Augustin, sorry.
Yeah, it's like Justin, but with a UG. Also, you can check out Flowlistic on all the social channels and check out his Patreon campaign as well.
Yep.
I am a patron.
Yep, lots of really cool designs coming out. Check those out.
Cool. That's it?
That
Are we
is
Q&A in it now?
Yep, this week's Q&A.
Excellent. All right. If you folks have any questions, anything that we talked about here or anything else, let us know.
So
We're here
Lewis from Ultimaker is saying, don't forget about cooling fans.
Yeah.
Be able to cool all that plastic that's being extruded. He had to go down to 30 millimeters a second for the 1.58 nozzle that he drilled out.
Whoa.
That's a good tip on that. I'm always scared of drilling out nozzles, like scared like I'm not gonna get it nice and straight.
Well, it's
like
because
it's
you
gonna
use
go
a drill
crooked.
press.
Yeah. That's a good
That's,
reason.
that's the best way.
Thanks for hanging out, Bill.
Yep.
Binko.
Thanks. We'll stay in touch. So later tonight, guys, is show and tell. So if you want to showcase your projects with Lamar and Phil, you can do so. Or you can watch makers from all around the world share their projects, things that they're working on. A lot of great stuff. It's tonight at 7:30 p.m. Eastern Time. And then later at 8 p.m. Eastern Time is Ask Engineer with Lamar and Phil.
Yep.
So new products. We'll love to see what new products are out. All the news from the open source worlds, Raspberry Pi news, Arduino news,
And even
and
some
more.
sneak peeks.
Maybe
at
some sneak peeks.
secret upcoming products and projects.
Sure. So that's happening later tonight.
Mm-hmm.
We'll also have another coupon code. But this one's good till tonight, I believe.
11:50 p.m. tonight. Take advantage of that. Don't pay full price for any of the products.
Cool. Use a lathe, says Lewis.
Oh, yeah. Somebody's asking, what Mac are you using to do the streaming?
I'm using a iMac, the 27 version, the maxed out one. It's like fully maxed out. I took no expense on this computer. It's fully maxed out. Although I could upgrade the RAM a little bit more, but it's doing pretty fine. Yeah. Mainly because I want to be able to do layer by layers where I can showcase the full screen. Okay.
I think that's it.
Wow, light show today. Well, thank you guys. Unfortunately, we won't be at the show and tell, but you will see everyone else at the show and tell, namely Lamar and Phil. Cool. Well, thank you guys again for joining us. If you do want to get anything in the shop, go ahead and use our coupon code. Just a real quick question. Charles is asking, how do you get the hobbyist license for Fusion 360? Just sign up through the website. I have a download link below for downloading it, and it'll guide you through how to set up your account and pick the right license. There's a little confusion there always because it looks like the license is only for a year. It is, but after that year, you just renew it.
Yeah.
Continual renew. So
Yeah, they
it's
need
great.
to work on the wording for that, but
Yeah,
yeah,
it's a little
should be safe to download for free.
Bitstab. Yeah. All right, cool. Well, we'll see you guys next week. Again, quick programming note: we're on Wednesdays now because we used to do it on Thursdays. Cool. Thank you guys so much. We'll see you next week, and happy making, everybody.
Have a great one.